For years, artificial intelligence was a brain in a jar. You asked a question, it generated text, and then it forgot you existed the moment you closed the tap. These models were brilliant, but they were effectively isolated from the machines they lived on. Openclaw changed the architecture. It stopped treating the AI as a conversationalist and started treating it as an operator. This framework gave the model direct access to read local files, browse the web, and execute terminal commands. The response from the developer community was immediate. A project that began as a weekend hack reached 190,000 GitHub stars in just 60 days, becoming one of the fastest-growing repositories in history. AI stopped simply generating responses and started executing processes. By moving the logic from a remote server to a local gateway, users gained direct, sovereign control over how their machines perform work. That shift toward local sovereignty triggered a massive corporate reaction. In late 2025, Meta acquired the agent framework Monis AI in a deal valued at over $2 billion. Meta is betting on a virtualization-first design. Every time a user assigns a task, Monis spins up an ephemeral virtual machine in the cloud. The AI acts autonomously, but it does so inside a corporate-managed sandbox, isolated from the user's actual hardware. This creates a divide even if it means granting an AI model unrestricted access to their personal files. The choice is now binary. We either delegate our autonomy to corporate-managed cloud environments, or we accept the high-stakes responsibility of running agents on our own infrastructure. To understand the risk, we have to look at the anatomy. At the center is the large language model. This is the reasoning engine. It takes an objective, like research these competitors, and breaks it down into a logical plan. The Openclaw gateway sits on your hardware and translates that plan into actionable terminal commands. It bridges the gap between the model's abstract reasoning and your computer's actual file system. Its power comes from ClawHub, a decentralized registry of over 13,000 community-built skills. These act like a modular nervous system, allowing the agent to instantly learn new capabilities. With a few commands, it can manage GitHub pull requests, scrape data from dynamic websites, or orchestrate complex email workflows across Gmail and Slack. By combining a reasoning model with direct access to local tools, Openclaw transforms a messaging app into a self-running operations center that can execute tasks while you sleep. In March 2026, digital workflows reached the physical world. Deep Mirror integrated Openclaw into industrial stacks to manage warehouse floors and conduct cargo audits. They utilized Openclaw's new spatial memory system to turn raw LiDAR and camera data into a searchable world model. Instead of just reacting to the present, the robot can now remember where objects were last seen. By loading this framework onto the Unitree G1 humanoid, they connected natural language intent to physical motors and sensors. The robot no longer follows a rigid script. It interprets goals and determines its own movements. The same software logic used to organize a digital inbox is now managing industrial infrastructure. The AI's reasoning is no longer validated just by text, but by its ability to autonomously complete missions in the physical world. The features that make Openclaw powerful also make it a high-value target. To be effective, the agent requires unrestricted access to your terminal, your applications, and your files. That access was exploited in early 2026 with CVE 2026-25253. This critical vulnerability allowed attackers to achieve remote code execution on a user's machine simply by tricking them into visiting a malicious web page. Simultaneously, the ClawHub registry became a vector for supply chain attacks. Researchers discovered over 800 malicious skills that were designed to exploit the agent's high level of permission. These skills masqueraded as productivity utilities, but they contained macOS information stealers and credential harvesters. Users were inadvertently running unvetted code with administrative privileges. It is a convergence of three risks: private data access, exposure to untrusted content, and the ability to communicate externally. Together, they turn an autonomous assistant into a system-wide compromise. The scale of the exposure was massive. Security scans identified over 135,000 Openclaw instances exposed to the public internet, many leaking API keys and conversation histories because of unsafe default settings. This has created a new category of shadow AI. Highly privileged autonomous agents are now operating silently within enterprise networks, often without the knowledge of security teams. With the project's creator now working inside OpenAI, the responsibility for securing this infrastructure has shifted to a decentralized foundation. They are left managing a massive security debt as adoption continues to climb. Deploying autonomous agents without zero-trust isolation grants administrative control of our infrastructure to the models and the attackers who subvert them. For organizations with data worth protecting, the productivity gains are not yet worth the risk of total system compromise.